My name is Vivek Sharma. I'm an assistant professor in the Agriculture and Biological Engineering department. Dr. Lakesh Sharma asked me to give you an update on the Florida Agriculture Soil Moisture Sensor Network. Before I start this presentation, I would like to acknowledge the funding from Florida Department of Agriculture and Consumer Sciences Services to support this project from last 3 years now. We are in the 4th year, and we'll hope that this project will continue because it has lots of value, and we got very awesome results over the years. And I will share a few of the success stories in this presentation as well. Okay, so let me give you a background why we started this project. Florida is a home of the specialty crops, high-value crops, and every year we irrigate about 1.3 million acres in Florida, and which have a cash receipt of about $7 billion. But at the same time, we in Florida face both water quantity and quality challenges. For example, with the rising competition between urban and agriculture and other sectors, we have seen the water is very crucial, in terms of their use. For example, this map is showing you the projected increase in irrigated acre by 2040, which developed by Florida Department of Agriculture and Consumer Services. The blue color here is where we have seen the significant increase in irrigated acres, and especially in the Northwest and the Swanee River water management districts, we will see about 16 to 18% growth in irrigated acres in next 20 years or so. We just not face the water quantity challenge, we are also facing water quality challenges as well. Dr. Sidhu explained you the last presentation, how Florida is working toward the water quality challenges. For example, this map here shows you some of the impaired water bodies that we have in the state of Florida. And that is a result of increasing nitrate, nitrogen concentration in water bodies that can impair the water bodies, as well as we have a harmful algal bloom as well. But at the same time, the year-to-year variability in climate also add the complexity in the water quantity and quality challenges. So, we are facing both challenges. So what we can do in this regard? So maximizing the net benefit of irrigated agriculture through a well-designed agriculture and water management network is very important and critical to the state of Florida. There are many best management practices, as Dr. Lakesh presented in the beginning. Success stories are in place. Either it's some nutrient management, water management, cover crops, and so on, right? But how we can estimate the benefit of precision irrigation technologies, that's the aim of this particular network, that is the Florida Agriculture Soil Moisture Network. When we talk about optimizing the agriculture precision irrigation technologies, that definitely have value, but excessive irrigation or insufficient irrigation are definitely both are determinative, have consequences to the crop. For example, excessive irrigation can increase runoff, soil erosion, depercolation of water and nutrient, which is a critical problem in the state of Florida. But at the same time, it can affect your grain yield, grain quality, environmental degradation, and it comes with an additional expense. For example, pumping, right? Insufficient irrigation also, limit your biomass, grain quality, and grain yield. So when we talk about precision irrigation technologies, what we need to focus on, we have 3 components that we generally focus on: when to irrigate, how to irrigate, and where to irrigate. Nowadays, we have a technology where we can actually say or tell where to irrigate in the field. We talked about variable rate irrigation technologies and so on. So how we can integrate soil moisture sensing technology in achieving these 3 goals. But another thing that we focus on, we talked a lot about nitrogen management or fertilizer management, right? We talked about 4 R's. I think everybody in this room or online, know about 4 R's, right? But one bad irrigation event can destroy your 4 R, right? So irrigation is a very critical component. I think you will hear more about, when Bob will talk about on the control release fertilizer and what's the effect of irrigation on, even you are more precise, very precise in your fertilizer management, one bad irrigation event or poor irrigation practices can overrule that effect. Okay, So let's look at how we irrigate land in the state of Florida. Most of our growers, this is the data from the USDA Farm and Ranch Irrigation Survey from 2018 and 13. Blue bars here is from 2018 and yellow bars from 2013. And you can see most of our land or most of our farms are still relying on condition of the crop and feel the soil or the crop. Only 5% of that use some kind of irrigation app, which is climate-based irrigation schedule, right? Which is based upon the crop evapotranspiration or crop water demand. About 16%, close to 16 to 14, 17% of growers or farms actually use soil moisture sensing device. If we compare that with 2013, this is 60% increase in the adoption of soil moisture sensing technologies in the state of Florida. So what are the main reasons? We saw this increase, but what are the main reasons? I talked with many people. There are three major reasons for this increase. One is industry support. You can see there's lots of industry, soil moisture sensor-based industry in the state of Florida that provide direct access of the technology to the growers, in not just the sensors, but also the support. Irrigation apps and IoTs, if you go back 2 decades, all the sensors were wired sensors where somebody has to go to the field, hook up your computer to collect the data. And that was a very tedious process, right? Nowadays, we have advanced technology where you can get all the data on your phone, iPads, by a cellular network, like any other app, right? So it's very convenient for grower to look at the data on the phone, and make the decisions. The other is the cost share programs. FDACs, as well as all water management districts in the state of Florida, have cost share programs that can provide funding to growers in precision irrigation technologies, and that include the soil moisture sensor technology as well. So these are the three big reasons that I find out is very valuable, increase or have a significant effect on increasing this adoption of soil moisture sensing technologies in the state of Florida. Okay, so what prevent growers on adopting water saving technologies? Again, this data is from the Farm and Ranch Survey. I think still, we have about 35% of the growers think that there is not enough return of investment. I installed the sensor, it's costly. Every sensor costs about, with all the subscription and hardware, it costs about $2,000 to $3,000. It's a huge investment, right? And if you have a big field, if you have 10 farms, you're looking at $10,000, right, or more. So what's the, how much investment that I put and how much gain I'll have out of these, Some are saying it's not a priority. Other is the finance, because again, it's the cost, right? I think there is one component that is missing in this 6 we highlighted here is the technical fluency of the stakeholders or the growers. Okay, we have the sensor. Okay, we are generating the data, but can we understand that data? How we can use that into our management practices? So that's another challenge that we generally face as when we talk to growers and other people. Okay, so how do we increase the technology adoption? I think one way is to grower need to understand the output from the soil moisture sensor devices. That's exactly what I was talking about, right? And they need to see firsthand, so applied learning, when they learn by doing, so when they install the sensor on their own, they look at the data and they, try it, for a couple of years, and then they are more comfortable in using the data in their farm production practices as well. So just to increase the adoption of technology, we started this program, Florida Agriculture Soil Moisture Sensor Network. The idea of this network is to educate growers as well as extension agents and to work with FDACs to increase producer adoption of irrigation best management practices throughout the state to conserve water. There are certain sub-objectives of that. One is the continuous expansion of the network, assist agents and growers in investigating soil moisture sensor as the water conservation technology. At the same time, quantify the operational and financial benefits of this technology. Generally, we talked about, okay, we have a soil moisture sensor. It's mostly used to conserve water. But there are some additional benefits, because I talked about how it is related to the nitrogen management or the nutrient management, right? So how much is the nitrogen reduction with the optimization of the soil with irrigation? How much you save in terms of not running your irrigation system or fuel cost, right, or diesel cost. So we are trying to connect all these components together. And lastly, providing information on sensor cost and cost share funding availabilities through different agencies that we have in the state of Florida. Okay. So we use certain model in this network. So agents join the network after, depending upon the priority in that area, they work directly with the grower. And if the grower is interested in using the soil moisture sensor, they join the network. Then they recruit farmers, right? And then they connect with the specialists so that we can install those sensors in their field. I, as the leader of this program, provide sensors to all our agents in different parts of the states, and they directly work with the grower to install the sensor in their field as well, and work collaboratively together. And then we, meet and discuss the technology, discuss the data and how they can change their management or water management practices. And at the last, we look into the outcomes, whether the growers are they understand the data or not, and how they can implement into their farm practices. Okay, we use different sets of technologies, different sensors, and we work closely with some of the local industries here. Some, for example, Centec drill and drop sensors, BMP logic sensors, EcoSpy sensors. All these technologies, they probably have the same principle. All are using capacitance sensors, but some are varied in terms of how data looks online. They have different web platforms. So this network also provide also share information on how different platforms, how we can get data from different platforms and use in the irrigation practices. Okay. We also work, we conduct different training programs, in-service training programs, workshops, one-on-one training to educate our agents as well. For example, from last 3 and 4 years, we have participated in many field days as well as in-service trainings and presented our findings in different seminars and sessions as well. Okay. So this was I was talking about before, data visualization. This is a huge challenge because this is the field climate platform used by the Holder Egg. This is the BMP logic platform. This is EcoSpy. All look different, right? And all have different sets of challenges and advantages. So how we can educate our growers on these particular visualization platforms is very important. So let me talk briefly about how we expanded this network. So the network was started in 2018 by Dr. Charles Barrett in North Florida. We had 20 units at that time. And now in 2022-2023 season, we expanded throughout the state. We had 76 units. We have about 100 units in our network. We have to retire a few units because of the age of the sensor. Now we have about 80 units, and 76 were installed last year by the network with the help of all the agents across the state. This is the estimated area that we cover with the state of with the network. In 2021, when we start looking at how much area we covered with that network, it was about 30,000 acres, and now we are approximately 300,000 acres throughout the state, which we actually work with growers and cover that geographical extent. This whole thing is possible because of the network of agents that we have in the state. I work with all the county agents, county faculty, as well as specialists to enhance this network. So this map is actually showing you where the agents are located, and I work with them very constantly so that we can show some success in this by this network. Okay. We covered many crops ranging from corn, peanut, peaches, some specialty crops, and you can see there's a list of crops here. We work with all these photographs showing you just for 2023 season where the sensors were installed in different fields. Okay, so we have many success stories. I know we are limited in time, but I'll share very quickly a couple of that. This is from the South Florida. I work with Mr. Craig Frey, Anna Melrose, and Christian Kammerer. We had 28 sensors in South Florida, Southwest Florida, installed in different commodities: dragon fruit, beans, cilantro, covered about 200,000 acres. Just because of the installation of sensors in different fields, now we have participants or growers have purchased or cost-shared 30 more soil moisture sensors as a part of their production practices. So this is a great thing that they are going for the cost share, which is available to them. As an example, just one grower, we estimated about 3 million gallons of water saved just using the soil moisture sensor. This is from Marion County, where we installed the sensor in passion fruit, and after 2 years of work, consulting with farmer on the regular basis, we estimated about 1,690 gallons of water saved per day. So this is again huge saving that we come with a small acreage of passion fruit as well. Another is in Manatee County, where I work with Christian Russo. It's not always about the water saving, right? If we have improved crop, so this is an example of where we looked at the data from before and after, and in soil moisture data, and then we also recommend to change, what practices they can change that include the salt production in Manatee County. Last one, I think Dr. Vivek Sharma already shared this thing. So we have 6 automated sensors installed in the compost application project in Putnam County, working with Wendy Mussolini on that. And this graph shows you how the compost application have increased the water holding capacity of that farm, and this soil moisture sensor help us to measure all the activities happening in that farm as well. The other thing that so soil moisture sensors sometimes come with the integrated weather network that also provide you soil temperature, air temperature, and so on. In this particular example, if you see here, in the last, soil moisture sensor was installed in citrus field, where grower was closely monitoring soil temperature as well. And that helped us to helped him to manage the freeze protection. And he saved about 1.1 million gallon of water, not just applying irrigation, because even the air temperature was low, the soil temperature was not as low as that at that point. So he didn't apply that irrigation and saved about 1 million gallon of water, just not applying water for freeze protection. Okay, sorry about that. So overall impact, definitely this network is bringing the cultural and behavior change in technology implementation, resulting in water, nutrient, and energy savings. We conducted many workshops. About 1,000 people participated. About 80% of that have gained knowledge on soil moisture sensor technologies. The middle 2 points, this is important. I actually worked with different water management districts. I asked the data from them, how many cost share, you have done over the years. So this is the data from 2 water management districts in the Swanee River Water Management District and St. John Water Management District. Since 2020, Swanee River Water Management District have approved about 601 soil moisture probes as a part of cost share program, which representing about 49,000 acres. Since 2020, St. John Water Management District have approved about 207 soil moisture sensors, and these numbers are coming from them. So this is again a huge success story for how with the help of this network, we are changing and adopting soil moisture sensor adoption in the state of Florida. We also prepared surveys. I talked with growers, interviewed growers. We are still in the process of that. And on an average, we are looking at average water conservation of 0.5 inch to 1.5 inch per growing season. If I just use that number on an average of 1 inch water saving in a growing season and 300,000 acres that we have in this year, it comes out about 8 billion gallons of water that we saved in just 2023. So you can see, these are estimated numbers. Again, we are doing the surveys and interviewing growers to estimate the exact figures, how much water we saved. But this will give you an idea of the importance of this network. Again, I haven't shown you the result of how this tied up to the nutrient or fertilizer saving and the energy savings, but this number itself tell you a big story here. With that, I'd like to acknowledge there are lots of agents, as you shown in one of the slides, are working in this platform, in this network, and the whole success of this program is because of them, who are working in this. At the same time, I would like to thank Florida Department of Agriculture and Consumer Services for providing the funding, University of Florida Extension, my department, ABE, providing all the resources, CLU, for all the guidance, and as well as the BMP mini grant, who supported this project at the beginning of the initial years. Okay, with that, I'll stop here and thank you and open to questions.